On SPSS, we have two tabs or windows. So we have the first tab, which is the data view. Here, as you can see, we have variables on this axis and we have numbers on this axis. So the variables correspond to the different questionnaire items like gender, age, education, etc. And these numbers correspond to the respondents. And in these cells, we have what we call the responses of the respondents to the questionnaire items, or in other words, we call them values. Those values like strongly disagree, neutral, agree, strongly agree. These labels or these answers can be labeled or coded. So there is a video that shows how to code the questionnaire items so that they can be processed using SPSS. On this window, we put the questionnaire items like gender, for instance, and automatically its type will be numeric, with decimals, etc., and label. So this is the name. The name should not contain any space or strange characters, whereas the label can contain space, etc. And in the values, we give them codes and names. So the code, for instance, one is going to be female, and two is going to be, for instance, male, etc. And click OK. So now we define this first questionnaire item. If we just double click here, we are going to move to the data view, or we can just switch the view from here. For example, gender, let's say the first person who filled out the questionnaire was female. So it was 1. I can just toggle this to see the values and labels. The second one was a male, etc. So this is how we can fill out questionnaires in case we have data extracted from paper-based questionnaires. But if you have Google Forms, there is a video that explains how you can code that fast and extract the data fast without errors, because here when we are entering the data, there may be a lot of data entry errors. So once we complete all the data entry like this for all of the other items, we can move to what we call descriptive statistics. From this tab, we call it analyze. We go to descriptive statistics, frequencies, and then we can move the variable here. And in statistics, we can choose, for example, some of these descriptive statistics of central tendencies like the mean, median, and mode, or dispersion like standard deviation, range, variance, etc., along with normality and percentiles. So we can just click continue if we don't want any of these, because this variable is categorical variable, not ordinal or a continuous variable, in other words. So we can just click continue, and we can click create APA style tables if we have SPSS version 27 and above, and click OK. So as you can see, here are the frequencies and percentages on SPSS output in EPA style automatically. So this will save you tons of time when it comes to editing. So let's move to Likert scale example. So we have this Likert scale in which we have motivation and achievement measured on 5-point Likert scale. If we go to the variable view, we can see how they are measured. For example, 1 corresponds to very low, 2 low, 3 moderate, 4 high, and 5 very high. Here you can have strongly disagree, neutral, agree, and strongly agree. Make sure that the lower values correspond to the lower levels. We don't want to have, for example, 1 corresponding to strongly agree or very high. It doesn't make sense, because SPSS does not understand the labels, it understands the numbers. So make sure that the numbers correspond to the labels in a logical and gradable manner. This is as far as the coding is concerned. Here for the numeric type, so here we can just toggle between numeric and string. String refers to characters, whereas numeric refers to numbers. For the measure, as you can see, Likert scale can be nominal, ordinal, and scale. I can share with you an article that I have been writing. Now it's in their consideration that you can check. So in this article, there are some spotlights in which I stated that the Likert scale can be nominal, interval, or ratio depending on your research objectives, questions, and hypotheses. Okay? Suppose that we want to test the frequencies of those who say agree, those who say disagree, those who say neutral. In this case, Likert scale is nominal. Suppose we want to measure the frequencies and percentages of those who say strongly disagree, those who say disagree, those who say agree, and those who say strongly agree. In this case, Likert scale is nominal. And I can analyze it using analyze and go to tables, custom tables, and I'm just going to move these two variables that are Likert scale, or just one of them here. And I can just click category position and click row labels. And in summary statistics, I will just include a percentage. And click apply to selection and close, and then OK. As you can see here, Likert scale is nominal variable. Here we can see how many people have moderate motivation and how many people have high motivation. The others do not have any type of motivation. So this is the case in which we consider Likert scale as a nominal variable. Another thing is that we can consider Likert scale as ordinal. SPSS does this automatically, by the way. Or we can consider it also as a scale. If we consider it as a scale, we can go to the recently used dialog box and custom tables. What can happen here is that we can just get this back and we can get it to rows. And I go to summary statistics. You can see here the mean automatically. So I can include, for example, the mean, the standard deviation, etc. Like the median, mode. I can include all of these. So we can have the sum, the standard deviation, and click apply to selection, close, OK. As you can see here, this is the mean score, 3.82, and this is the standard deviation. So how can we interpret this? So if you can, that's why I told you make sure of the coding. So if we just go back to the code book, this one, you can see, for instance, that 3 corresponds to moderate score. This means that most respondents have moderate to high motivation, so it moves from 3 to 4. In this case, it's 3 point something. So as you can see, 3.82. So almost the majority of respondents have moderate to high motivation, or we can say high motivation, because 3.82, that's approaching 4. So as you can see from the frequencies, this frequency backs up this mean. So here the majority of respondents have said that they have high motivation. We have 234 respondents, and the percentage we have 82%. That's why we use the mean to support the frequencies and percentages, and we can use the mean to analyze Likert scale items and also Likert scale as one or as different items. In that sense, we will have the weighted mean or the grand mean. Some researchers also call it the composite score or the mean score. Okay? And also that is used with some tests or the test significance, like correlation, regression, ANOVA, and t-test, among others. So this is how we can consider the different types of statistics. So for the normality, some researchers ask about the normality. So the vast majority of Likert scale items can be subject to non-parametric tests because the data is not normally distributed. However, if the sample size is bigger than 30 cases, we can use the parametric tests because there is an approach that we call sensitivity analysis that comprises using both parametric and non-parametric tests. Another point is that we can also use ChatGPT to make sense of these statistics. So we can just copy these and we go to ChatGPT and we ask it to be it 3.5 or 4 and we ask it to interpret the results. EPA, for instance. And then it will interpret the results, like motivation levels varied among the participants, with majority falling into high category, and we have the percentage and substantial proportion of participants also fell into the moderate category. Of course, we need to modify or edit this output because they are not participants, we call them respondents rather, participants like in focus groups or tests. So here we have the average motivation and standard deviation. So the standard deviation just tells you the difference between people in terms of the motivation here, in terms of the Likert scale content. As you can see, this is low standard deviation. This means that this group is almost homogeneous group. And this is proven also by descriptive statistics of the frequencies and the percentages. So most respondents are not different from each other. Like if the standard deviation is high, like 3 or 4, we will find like some people are very high or do have very high motivation and others have very low motivation. In this case, we can consider that this sample is heterogeneous and not homogeneous sample since the standard deviation is big. We can also use some inferential statistics with regard to Likert scale data analysis, in which case we consider it ordinal or continuous. So once we go to analyze, and we can, for example, use correlation by going to correlate bivariate correlation, and we are going to include these two scales here. Although this is coded as categorical, still SPSS will treat it automatically as a continuous. So SPSS does the treatment automatically. Also, if there are missing cases, SPSS will deal with them automatically without having to code them, etc. And we have different types of correlation. We have Pearson, we have Spearman. We can use both. For sensitivity, we can use Pearson and Spearman correlation. And the test of significance, this is where the trick happens because you need to know your hypothesis. Like if there is one direction of your hypothesis, like if, for example, motivation leads to increased achievement, this is what we call a one-tailed hypothesis. If we say, for example, both motivation and achievement are correlated and we don't know the direction of the hypothesis, whether, for example, the correlation is positive or negative, this is called two-tail. So depending on your hypothesis, we can choose. And if you change these, you will get different results. So you should be careful with regard to it. So here we can also show only the lower triangle, show diagonal, especially if you have SPSS version 27 and above. And once we click like options, we can also add the means and standard deviations. And we have also, once we click OK, we will get the correlation table, as you can see. So this is the correlation coefficient. It says that there is a statistically significant strong positive correlation between achievement on the one hand and motivation, and this significance is below 0.001. So it's very highly significant because this data is just fabricated data, so it's not true. So you can see this one 100%. Normally it can be negative, non-significant correlation, etc. So this is the correlation table for the Spearman and also the Pearson. The Pearson is the parametric correlation, whereas the Spearman is the non-parametric. And in this case, we use them both just to tell you that both of them show the same results. And this approach is called sensitivity analysis approach. So I talked about this on the article that I will share its link with you below. You can see here the mean score. We have the same mean score. because I said this is just an example data, and we have the n that refers to the sample size, and the same standard deviation. Examiners can also detect that the data can be fabricated or not true data. So there are a lot of tests to reveal that. So it's better to use real data that is self-reported by people. Anyways, but just for illustration, we can also test regression by seeing whether motivation will predict achievement. To do this, and whether that impact is positive or negative, or there is no impact. To do this, we can go to Analyze, Regression, and then Linear. And then I will put the motivation in the independent list and the achievement in the dependent list. Although here it's categorical, still SPSS will automatically treat it as continuous. And then I don't want to check any of these. I want to make simple analysis. I will click OK. And here is the regression. Here we have values lacking because there is 100% correlation, as I said. This is not real data. But normally what you need to find here is that you need to find a significant p-value here for the ANOVA. Although we are using regression, this ANOVA tells you whether this model fits the data or not. This should be below 0.05, and this should be also below 0.05 to see whether motivation has a statistically significant impact on achievement. And the nature of the impact is tested using the beta and standardized coefficients. Here, if we find, for example, negative, we will say negative impact. If we find it positive, we say there is positive impact. So this can be interpreted as there is a statistically significant positive impact of motivation on achievement. So this is regression in brief. And there are other tests like structural equation modeling. There are also other tests like ANOVA, chi-square, t-test, etc. So I will be posting other videos that explain this in detail. And if you have questions or remarks, do not hesitate to post them below. And see you soon.